this video, we'll talk through part 2 of the formula and equations topic from National 5 Chemistry Unit 1. By the end of this video, you should be more confident in being able to predict the shape of molecules when given a formula, be able to write an ionic formula for a compound, be able to correctly use the state symbols in an equation, and also be able to balance chemical equations. There are 4 shapes that you need to be aware of. Know about linear shapes, we need to know about angular shape, trigonal, pyramidal, and also tetrahedral. Types of questions you can be asked, they'll give you a particular chemical, such as chloroform, which used to be used as an anesthetic. They give us the diagram and ask us to describe the shape of this molecule. We have got one central atom with 4 other atoms attached, therefore we have our tetrahedral shape. A way they can make it a little more difficult is they'll name the chemical, but they will not tell you the formula. What we will need to do first of all is work out the formula of phosphine and then figure out which shape it marries up to. Our phosphine has got phosphorus and hydrogen. Phosphorus is in group 5, so makes 3 bonds. Hydrogen in group 1 makes 1 bond. Swap them over, gives us pH3. When we've got pH3, if we look at the diagrams that we're given, this will match up best to trigonal pyramidal, making our answer B. Next, we'll talk about our ionic formula. An ionic formula shows the charges on each ion. Na plus Cl minus would be the ionic formula for sodium chloride. An exam question might ask you for an ionic formula of a particular chemical. What I would do first of all is work out the normal formula for it, and we'll add in the charges at the end. We've got Na and H, both of which in group 1, both of which make 1 bond. So our chemical formula would be NaH. When we look back at their valencies, our metals tend to be positive, and our non-metals would then tend to become negative. We've got Na plus and then H minus. Our hydrogen would sometimes have a positive charge if it's talking about acids and alkalis, but in this question, this is going to be our negative ion, and our sodium is going to be our positive ion. In this question, they give us the formula and want us to work back to determine which charge is going to be on our ion in this compound. We start off by looking at our formulas that we've got for the 2 parts. We also know what our end formula is going to be. Looking at the formula we're given, this means that at the end, after valencies have been swapped, the iron goes with the 1 and the nitrate goes with the 3. We know that nitrate has a valency of 1 because it's got a 1 minus charge in the data booklet on page 8. This means that the 3 has to have come from our iron. And if the 3 has come from the iron, because we've got iron metal, this is going to give us a 3 positive charge, which gives us the answer of B. We could run it through forward to double check it and make sure that we've picked the correct answer. Also need to know about state symbols, where if a substance is solid, we use the letter S to represent that. We'll have L for liquid, G for gas. If we have a solution, we use AQ. AQ is used, which means aqueous solution. This is from water being used as a solvent for a particular solution. In this example, they give you a description of a chemical dissolving and ask you to pick the correct equation for this. It says that we've got sodium chloride solid and water is a liquid. This can rule out 2 of our answers. It then tells us that we make a sodium chloride solution, which means that D is going to be our correct answer. Next thing we'll look at is balancing chemical equations, and this allows us to have equal quantities of reactants and products, and there must be an equal number of each atom on each side. Take an example of magnesium burning in oxygen to make magnesium oxide. When we look at what we've got at the start, we have got 1 magnesium on both sides, but we've got 2 oxygens on the left, but only 1 on the right. To fix this, we can add another MgO. We cannot change the formula of magnesium oxide. That is determined by its valency and is MgO. We've now solved our oxygen problem. But we've now got 2 magnesiums on the left and only 1 on the right, so we need to add another magnesium to our left. When we have now got the same number of each atom on both sides, we count up how many of each part we've used, and we write that as a number in front of our term in the equation. We've got 2 Mg's, got 1 O2, and we've got 2 MgOs. And we now have a correctly balanced equation. If we look at a second example, we'll start by fixing our chlorines, where we've got 1 on the left and 3 on the right. Now we've got equal numbers of chlorines on both sides. We then look at our hydrogens, and we'll go to try and balance this. If we add a second H2, we've now got 4 on the right, only 3 on the left. Therefore, what we need to do is we need to have 6 HCl's now and 3 H2s on the right-hand side. Once we've done this, we need to add a second aluminium chloride to make sure our chlorines stay balanced on both sides. And we need to add a second aluminium to the left to make sure we've got the same numbers of each atom on both sides. And we then write this as 2Al plus 6HCl, reacts to give 2AlCl3 plus 3H2. Typical type of question might be giving you an equation and just asking you to straight up balance it. We have got our chlorines are unbalanced at the moment with 4 on the left but only 1 on the right. We can then put a 4 in front of the NaCl. Our chlorine has now been balanced. However, our sodiums now, we've got 4 on the right and only 1 on the left. Therefore, we'd need to change it to 4Na, and now we've got everything balanced on both sides, and we have got our final equation of TiCl4 plus 4Na gives us Ti plus 4NaCl. Another question I like to give is where they give you different options for the balancing numbers, and you have to pick out the correct one. First thing we'll look at is our ions, where we've got 2 on the left but only 1 on the right. If we add a 2 in front of the Fe on the right hand side, we've now got equal numbers of ion on both sides. But now we have the issue of carbons, where we've got 1 on the left and 3 on the right. We can then put a 3 in front of the CO, carbon monoxide, and our carbons are now balanced. The oxygens on each side as well, there's 6 on both sides, meaning we have fully balanced this equation, and our correct answer is answer C. Hopefully by the end of this video, you feel more confident in predicting the shape of molecules from formulas, being able to write ionic formula for a chemical, knowing how to use the correct state symbol, and also how to balance chemical equations. Thank you for watching. Goodbye.